So the CHLORINSITU 2A medium has on the left side of the unit has 4 connections. The top connection is filling the brine tank. So softened water is going to the brine tank to maintain a softened water level. The second connection is the actual water supply line. In this case, it's softened water that runs into our device. The third connection is the product oxidant outlet going into the storage tank. And the bottom one is the actual brine input. So our brine pump sitting inside the cabinet is pulling brine from that same brine pump tanking. Now we'll move to the machine itself. Switch on the power. So the machine itself has 2 cabinets, a production cabinet and an electrical cabinet. Everything is controlled by a Siemens PLC and a 10-inch HMI. So with our key, we can open these doors and we can see the inside of the electrical cabinet. And I'll open this door, and now we can actually see the inside of the device. Now we have a separation, the electrical cabinet and the production cabinet. All the wires from the production cabinets go overhead into the electrical cabinet and can be installed on our terminals. So if we look a bit closer to the production cabinet, then we start with water coming in. So over here, the softened water supply is coming in. And then we meet this T section where we divert into this solenoid valve and into this solenoid valve. That solenoid valve is opening and closing to fill the brine tank. This solenoid valve runs through a flow regulator and then into this flow meter into the back of this cell. This is the hypocell. In this installation, we have 2 hypocells. So water and brine is going into the first hypocell that is overflowing into the second hypocell and then overflowing through this discharge system into this degassing tank. Now we go back to our water supply system. So we run water through the valve, flow regulator, the flow meter, and now over here it is meeting the brine injection. So in this injection valve, brine is being injected by this dosing pump. So the suction line of this dosing pump is connected to the brine tank, and the discharge line of that dosing pump is in this injection valve, where it's injected with the softened water stream going into the first hypocell. So that is the water plus brine entrance into the cell. From the cell, the output of the oxidant overflows into this standpipe where hydrogen is separated from the liquid. The liquid will drop down over here into the degasser tank. We call this the degasser tank because we are degassing hydrogen from the solution. So all these transparent piping is where hydrogen escapes and runs out of the system. So this is the hydrogen dilution vent pipe. The hydrogen is diluted by a fan. The fan is located behind this junction box, and this fan is blowing air into the degasser tank, and that air with the hydrogen is going outside through this hydrogen pipe. So the hydrogen is diluted under 10% of the level. To safeguard that, we have 2 sensors. We have one analog sensor and we have a digital switch. So we are measuring the actual airflow going through this pipe, and we have a switch that is detecting airflow at a specific rate. So that is the hydrogen leaving and being diluted in the degasser tank. So the oxidant tank, the oxidant will be filled into this tank, and the level will be rising. So during production, the level in this tank is rising with oxidant, and that is measured by this pressure sensor. The pressure sensor is indicating on our HMI what the actual level is, and when it's reaching a certain amount of volume, the booster pump will kick in and will transfer the content into our storage tank. So the booster pump is VFD controlled, and it will empty this tank to a certain level where in the same amount of water going in is the same as the outgoing flow. So he is maintaining a constant level in the degasser tank. Next to the pressure sensor, we also have a too high float. So if the level is rising too much, it will meet this float, and that will generate an alarm. Now the discharge of this booster pump is in the back, where we have another flow meter, a check valve and a ball valve. So that outgoing flow meter is counting the amount of pulses that we are transferring into the storage tank. The check valve is there that nothing can throw back, and the ball valve is there to isolate the entire pipe section. Now, if we move over to the electrical cabinet, we have our PLC stack. We have our VFD to control the booster pump. We have our contactors, our circuit breaker line, and we have our power supplies for our 2 fans. And this is the heart of the... On our HMI, we have the process flow laid out, and all the components have their own pop-up menu. So if we look over here, we have the water supply coming in with a differential pressure switch. That water supply is meeting the softener. The softener has water hardness measurement in there. And after the softener, we have 2 solenoid valves. We have one going to the process water that is filling the cells, and we have one fill brine tank solenoid valve. Here we have the brine tank. So there is a line connected from the brine tank into the softener, which is brine necessary to regenerate the softener. So all these green or grayed out bars are indicating the status of this component, which in this case would mean that the softener is running and this level is okay. So softened water runs through the hardness measurement, runs through a flow meter over here, and the flow meter is indicating the actual flow going into the cells. Over here we have a brine pump, which is controlled between 0 and 100%. So depending on the flow, this has its own control. So we see that softened water and brine is meeting up over here, and then it flows through a temperature sensor into the first hypercell. So we measure the temperature of the incoming water supply. And this is important because the temperature has to be at least 40 degrees Fahrenheit for salt to dissolve in water. We also don't want to have a too high a water temperature coming in. Now when it goes into the hypocell as a brine solution, it will be transferred into oxidant, overflowing into the second hypocell, and then leaving the second hypocell also with a temperature sensor, and then it overflows all the way into the degasser tank. Now, if we touch or press on each component, it'll open a pop-up menu. And this pop-up menu has the set points. These can be a set point or an alarm set point. It also, through each pop-up menu, there is an overview of all the production settings. So if we hit this bar, we can see all the pop-up menus of all the components. And then we can run through these different menus to see all the settings. So if we close him, now we have our main screen again. So oxidant is leaving the cells and is filling the degasser tank. Over here we can see the level of the degasser tank that's coming from that pressure sensor. And we see if the fan is running or not running. On the outlet side of the degasser tank, we have our booster pump and we have our flow measurement. From the booster pump, we are going to the external storage tank. That will be on the second page. This is an important section. This is our ventilation of the airflow. And we have an airflow switch and we have an airflow measurement. So during production, we have a different target airflow as when the unit is in standby mode. So now the unit is in stop mode, so it is in standby. In standby, it wants to achieve or maintain 130 CFM airflow. To do that, the fan is running now at this moment at 53% control. So it means that the status is okay. The air switch is a different component. At this moment, in standby mode, the airflow switch has not to send a signal. So we see on this icon over here, we see a grayed out field of a relay. That means that the airflow switch during standby mode does not give a signal to us. This will change when we start the production. So if we start the production, he will go. The target airflow in production is 190. That means that this control will ramp up to achieve 190, and then this icon has to turn green. So we go out. So that is the flow of water turning into oxidant going to the storage tank. Other side over here on the left, we see the status of the hyposurge. And this is amperage and voltage measurement. So amperage and voltage are the two main parameters of an indication how much chlorine the unit is producing. So if we click on here, we have a set point current of 123 amps and a maximum voltage of 24. So that means that our power supplies are controlled to achieve 123 amp on the cells. Now, below here we can see all the set points of all the alarms. So we have a low current, a high current, a low voltage, and all our delay times on these alarms. We also have a cooling fan inside the electrical cabinet. If the temperature inside the electrical cabinet reaches a temperature above 125 degrees Fahrenheit, the actual fan inside will start cooling. Also here from this pop-up, we can go to all different settings menus. From here, the oxidant is going into the external storage tank. So if we hit this button, we can actually see the storage tank. The storage tank has an ultrasonic sensor that is measuring the level inside the storage tank. It also has a level too high. This is an actual float that is hardwired into the PLC. So from the storage tank, we have, in this case, we have two dosing pumps. These two pumps are drawing from this storage tank, injecting in these two lines. based on an ORP or on a total chlorine sensor. And we, of course, we have a flow switch saying that there is water going through these sensors. Based on the flow and this flow, these pumps are injecting oxidant into these lines. So we have a button here that says the status of the production, status of the storage and the dosing, and we have a section alarms. In a different video, I'll explain all the different alarms. For now, we also have in this menu at the top, we can go next to the statuses and the alarms to a system menu. Now this is allowing us to see more than just the operator. We can adjust the language, we can adjust time, and the service menu is something very helpful. In the service menu, we have an I/O test, and this is saying the status of each individual input that's going into our PLC. This is saying the status of each individual output and a service menu to toggle those outputs. Then we see all our analog in and outputs. We also can see the alarm history. So each alarm, incoming or removed, is stored into our history. So we can go back into history and see if there are recurring errors. We also have an option of maintenance that is behind a maintenance password. We have a system view PLC where we can see if all the PLCs in the installation are connected to each other. We also have a PDF viewer option. Inside the HMI, there is an SD card. If you take the SD card out, you can upload PDF files and you can display them over here. Display settings, we can adjust the brightness of the screen. And we have two options over here that are important with startup and maintenance. So we have an option for filling the hypocell. If you press confirm, you are putting softened water and brine into the system for a startup. Flush the hypocell is we are only letting softened water in for 5 minutes. Documents is where we have the different documents stored that we can display on the screen. Factory settings. The manufacturer can enter into the settings to change the actual default or factory settings of this device if need be. These are the settings for the ultrasonic sensor. So we have the height at 4 milliamp, the height at 20 milliamp, and the diameter of the storage tank. So with these numbers, we can calculate the volume inside the storage tank and we can assess alarms. We also have the option to calibrate the chlorine sensor. So the measured value with your DPD test kit can be input over here. And if that is this value, calibrate, and the actual value will be taken over there. And then we have a salt filling table. Every time we add salt to this system, we can enter your name, the amount of bags, and the date where you actually place that salt. With this, we can store or create a log file of when salt has been added. With this button, we can go back to our main screen. This is the home screen. where we can start and stop production. We can start and switch off our dosing pumps. We actually see if there is demand to fill the oxidant or the storage tank. The status of the enable. The enable contact is a signal that an outside entity can place into our system to stop or start the production.
Yes.
The status of the softener can be running or regenerating. Over here we have a short overview of the main parameters. So the control of the dosing pumps, the level inside the storage tank, the flows through the aux and recirc line, and important, the amperage and the voltage on each cell. Also displaying is the total chlorine and the ORP measurement. We can start and stop the production with this button, but we can also start it over here.